This video is going to go over a common algorithm for dynamically adding an item to an array in C++. Arrays have a fixed size and are kept track of by pointers. We can't modify the array's size in place, so adding an element to an array involves the following steps. Allocate memory for a new array with the new size. Copy the old array into the new array. Deallocate the old array. Add the new value to the new array. Update the length variable. And finally, update the array variable to point at the new array. Let's explore code that will accomplish this using an array of floats. In our main function, we'll declare two variables. One, a float pointer, which will point to the array, and the other an int, which will hold the size of the array. To begin with, the length variable will be set to 0. Because the array will start out empty, it takes up no memory, so no memory needs to be set aside for it. Let's add delete to our current code, because the array should be cleaned up when the program exits. If we were to compile and execute the code at this point, it wouldn't do anything, but it wouldn't crash, because it takes the precaution of initializing the pointer variable to null pointer. If the variable had been left uninitialized, deleting it could cause a crash. You will often want to free up memory at the end of your program, as here. But there will be other times that you will want to also free up memory. The important thing is to keep the new and delete calls in balance as you go. We'll see an example of that now as we code a function to add an element to the end of the array. The first parameter is a float pointer reference. That's complicated, so break it down into its parts. We are passing a float pointer in order to access the array. By specifying that the parameter is also a reference, it acts as an alias to the variable that is passed in. If the parameter weren't a reference, much of the function would still work. In that case, the new array could be created, and the values could be copied into it. But the array variable in main could not be updated to point at the new array. Using a reference allows us to do just that. We need a temporary pointer variable in order to store the location of our new dynamically allocated array. Once all the old values, if any, have been copied into the new array, it's safe to free up the old array's memory by calling delete. If we failed to free up the memory when needed, we'd have a memory leak. Every time we add a new item, a new array is allocated, and if the old one weren't freed up, they'd accumulate in memory. We then add the new element at the end of the new array, and update the length variable, which is also passed by reference. Finally, the array pointer is updated. Take a minute to watch what happens on the stack and heap during another call to append. Notice how the append method calls both new and delete, so they stay in balance overall. I hope this video has helped you understand this process and maybe a little bit about memory management. If you have any questions, please leave a comment. I'm always looking for new topics that people want covered in these videos. Until then, happy coding.